Today we are going to construct SDT to store type information in symbol table. Input is XYZ and output will be like this: variable name, variable type, integer. This is the grammar. S tends to D, D tends to D, ID, oblique TID. T is character, float and integer. So now we are going to make tree first. So D tends to D, ID. So you'll write D, ID. Again D, ID, D tends to, so you'll write D, ID. Now D tends to, T is also there, so you'll write D tends to T and T tends to ID. So T can be character, float or integer, so we are taking in because variable type is integer, so we are taking integer. And here X, ID, so ID can be, initially we are taking X and we can say X integer. Here one more time we need to take instead of D, like as we have taken here, so here it come D. D, ID, one more is required, so we will take here D, ID, and after that we will take T, and this is of integer type. Here we will take X, integer, and here it will be Y. Here it will be Y. In the similar way, here it will be Z. So Z, integer. So here we can see that this is T dot type is equal to int, and here D dot type is equal to int, here also, because variable of integer type that it is given input. This is also D dot type is equal to int, and here also D dot type is equal to int. So I will write SDT for this. S tends to D, that is optional. That is optional part. And D turns to D, ID. So how we can write it? We can write at type ID, D1 dot type, because it is given over here, this one, and we can say D dot type is equal to D1 dot type. Instead of here D, we can take D1 also, so that we can differentiate here. It is up to you, you want to take, otherwise leave it, no problem. So if we take D1 here, so we can write D dot type is equal to D1 dot type oblique T dot ID. T dot ID is here, so we'll write T ID. So we'll write here at type is equal to, or at type is what, ID, T dot type, because we are having T here. Here we were having D, so we'll write D dot type. Here we are having T, so we'll write D dot type. Or we can say simply, because this is D is equal to T, so we'll write D dot type is equal to T dot type. Now next is what, T. So we'll write for T. So T can be a character. So first we'll write T dot type is equal to character, because it is given. It is given in the grammar, this one. So T dot type is equal to char. It can be float. So we can write, because this is T dot type is equal to float, and integer is also given, so we can write t dot type is equal to integer. So in that way we can write SDT for the given grammar according to the input. So here we can say after completion of the child, parent completed, so this is S attributed. This is S attribute, or we can say bottom up, because first child get complete, after that children parent. So this is the way to construct an SDT for the restore type of information in the symbol table. So this will be the output. X, Y, Z are the variable name, and this is of integer type because we have taken our integer type. In this way it can be of float and character. It depends upon how we want to take.